Okay, AP Statistics, Unit 6. Woo woo! We have arrived at example 11. So here's the premise for this problem. Bicycles arrive at the bicycle shop. They arrive in boxes. So before they can be sold, obviously they have to be unpacked, they have to be assembled, they have to be tuned. Magical, magical. All right, so based on past experience, so this shop manager has collected data over time. He has found that on average, the unpacking process takes 3.5 minutes with a standard deviation of 0.7. The assembly process, 21.8 minutes on average with a standard deviation of 2.4. And tuning the bike, an average of 12.3 minutes with a standard deviation of 2.7. Okay, so please notice that you are given information up here. The times for each setup are independent, and the times for each phase follow a normal model. So just as you can transform one normal model and it becomes another normal model, the same thing occurs when we are looking at a combination. If you're combining normal models, you're going to get a normal model. Okay, beautiful. All right, so for part A, what are the mean and standard deviation for the total bicycle setup? All right, so the total average, you guessed it, kids, 3.5 plus 21.8 plus 12.3. It's a magical time. Addition is a beautiful, beautiful thing. Okay, magic. The standard deviation for the total, of course, we can't just add the standard deviations. We have to add the standard deviations squared, and then we have to take the square root of that. So we end up here taking the square root of 13.54, which gives me 3.68. So the new normal model for the total time is 37.6 with a standard deviation of 3.68. All right, groovy. All right, in part B, a customer decides to buy a bike like one of the display models but wants a different color. So the shop has one, but it's still in the box. All right, so the manager says they can have it ready in half an hour. So that's 30 minutes in case you don't know that. Do you think the bike will be set up and ready to go as promised? All right, so in other words, we need to see how realistic it is that this would occur. So there's a couple of different approaches you can take for this problem. You can base it on looking at the standard deviations, like how many standard deviations from the mean 30 minutes would be. You could think of it that way. You could think of it in terms of finding the probability that it would get done in as little as 30 minutes. What you need to consider is that on average, this whole process is taking about 37.6 minutes, give or take 3.68. So you need to recognize that there's a very high likelihood that it could take as little as 33.9 minutes, but it could take as much as 41.3 minutes because you're looking at below mean and above mean. So you need to keep that in mind as you're thinking about this. So you can explain it in terms of that if you would like to. But it usually helps to have something concrete. So how likely is it that this bike is going to be done in as little as 30 minutes? So if I take the probability approach, I've got to have an area of under the curve that I'm finding the probability of. So, or not the area I'm finding the probability of. Sorry, I misspoke. The area that represents the probability it will get put together in 30 minutes or less. All right, so when we think about this, the reason I'm choosing to shade away from 30 or to the left of 30 is because I don't care about this over here. Then it would be totally acceptable. I mean, I wouldn't even have to think about it because it would contain the average. So that would be normal to see that. I want to know though how likely it is that it would be as low or lower than 30. So I want the probability that x is less than 30 because that is going to be more unusual because it's farther away from the mean. So when I do this, I just use Staplet just like I have a million times, and I found a left tail, okay, below 30. And so I found a probability of 0.01945. That is the probability that I found. You could also take the z-score approach by just finding that z-score. You get negative 2.05. Keep in mind that the more standard deviations below or above the mean you are, the more unrealistic or the more unusual that value is. And as you can see, our probability is less than 2% that they're going to have this bike done in 30 minutes or less. So when you're answering this question, like I said, you can take several approaches. You can talk about the fact that this indicates it could be as little as 33.9 minutes or as big as 41.3 minutes. So you could use that approach, just what you know in general about standard deviation. You could take the approach of, hey, with a probability of only 1.9%, it doesn't seem likely. Okay, or you can take the approach of, since 30 is a little, not a lot, a little over 2 standard deviations below the mean, it seems unlikely that they'll get it done. Okay, so there's several different approaches you can take here, all of which are acceptable, but I would rely on one that enables you to show some kind of work.